Hello, class, and welcome back to your ASI 124N, your engineering mechanics 2 or your dynamics of rigid bodies. So, for today's lesson, we will talking about rectilinear translation. So, on this lesson, basically, we'll begin our study of dynamics by discussing the kinematics of a particle that moves along a rectilinear or straight line path. Basically, we will be talking about particles that move in a straight line in this lesson. So, at the end of the lesson, here's the learn outcomes that you must able to explain the concepts of rectilinear motion with constant and variable acceleration and free falling bodies. Next is you're going to apply the concepts to solve problems related on rectilinear translation and free falling bodies. So let's start for your constant acceleration. So in constant acceleration, your rectilinear motion defines the kinematics of the particle that moves along a rectilinear or straight line path. Yun lang bagay yung rectilinear motion nyo. Basically, particles that move in a straight line path. That's your rectilinear motion. Now, kinematics of a particle is characterized by specifying at any given instant that the particle's position, velocity, and acceleration. Basically, these are your motion parameters. So, in this lesson, we mag-focus lang tayo sa tatlong to. So, it's the position, velocity, and acceleration. Your motion um, parameters. So, ano nga ba yung position? So, the position, the distance of the particle from the origin or fixed point. Ayan. As you can see sa uh, axis natin dito, this is your coordinate axis. So your position daw is the distance of the particle from the origin of the fixed point. Let's say that your particle is this circle right here. And its distance daw from your origin of your coordinate axis, this is your position coordinate. No? So your S is defined, the distance of the particle to the origin is your position. And it's usually it is expressed in meters or in length na unit. Meters, feet, miles, kilometer, millimeter, inches, ganyan. It's your position. Next, it is a vector quantity. Take note, this is a vector quantity. So you have to consider its direction, not just its magnitude. If it's your particle will move to the right from your origin, it will be positive, and if opposite way will be negative. Okay, that's your vector quantity, your position. Next is your displacement. Displacement is the change of position of the particle. Yun lang. Basically, that's the difference between the initial and the final. So always, mag dapat una yung final no kahit sa sa initial nyo. So um, kunwari for this coordinate axis. So your position, your initial position is from the right, and your particle's final. No. Your initial is here, and your final is here. So this is positive. Okay? So kung pa-left naman, syempre, it is also negative. O pa-left, rather. So it is calculated as delta S is equals to S prime, your final position, minus your S or your initial position. That's your displacement. Next is your velocity. So velocity daw, the change of position of the particle per unit of time. So the the change of position, your displacement, di ba? We define that the change of position is your displacement. So basically, displacement per unit of time. So it's your velocity, like in this axis or coordinate axis. Here, there's a change in position and there's also time. So it is your velocity. Okay, again, your velocity is a change in position per unit time. And then average velocity daw, the particle moves through a displacement during the time interval. So that's your average velocity. And it is calculated by average speed is equals to delta S over delta T. Yun lang, change of position or displacement over delta T or your time interval. Next is your instantaneous velocity. No? A vector that is found by taking smaller and smaller values of delta T and the corresponding smaller and smaller values of delta S. So, instantaneous velocity, kumbaga, ano yung velocity at that instant. So, it's kind of very accurate na pag-define ng ng instantaneous, no? Instantaneous velocity. Okay? So, if we take the smaller and small values of delta t, no, the magnitude of the delta s becomes smaller and smaller also. So, consequently, it is calculated as v is equals to ds over dt, your differential unit of your position or displacement, and your differential unit of your time. So that's your instantaneous velocity. And that's our first equation because it will be used, no, as the lesson progress. Next is your speed. Now, the speed is the magnitude of the velocity and generally expressed in units of meters per second or feet per second. Average speed is sometimes used to refer the magnitude of velocity and always a scalar quantity. Again, scalar quantity, so magnitude lang natin yung concern dito. So, you don't have to care about the direction. So, the total distance traveled by a particle S sub t divided by the elapsed time. So that's your average speed. So that's a distance traveled by the particle and over the elapsed time. Next is the difference between average velocity versus average speed. So take for example this axis coordinate. So we have first position is here sa right side. And then your final position bumalik siya papuntang origin. So to the left yung ano niya, yung movement or its motion. So, basically, kung if we talk about average speed, diretso, kukumpute natin yung kung ilang distance yung na-travel ng particle natin divided by the total time na pag-move niya. So, that will be calculated as average speed is equals to total distance traveled by the particle over the elapsed time. Now, on the other hand, the average velocity now is negative delta s over delta t. So, bakit ganon? So, di ba, if we recall, average speed is a scalar quantity and average velocity is a vector quantity. So, we need to account the direction of the particle kung papunta ba siya sa right or sa left. So, in this manner, yung particle natin moves to the left, so it will be negative in average velocity. But in speed, hindi na kailangan i-account pa yon. So, total distance lang ng particle na travel divided by the time, yun yan yung average speed mo. But if the problem needs the average velocity, you need to account the direction of your particle. So that's your difference between average velocity and average speed. Okay? So, next is your acceleration. So, acceleration, the change of velocity of the particle during the time interval. So, this is the change, again, of the velocity. Siyempre, if you have your particle running at initially its velocity is 3, and the final velocity of the particle is 6. So, the change of that velocity is your acceleration. Siyempre, i-account natin yung time interval niya. Divided mo yon, so you have your acceleration. Now, expressed in units per meter per second squared, di ba? So, if you divide the meter squared, meter per second over second, so that will be meter per second squared. So, that's your acceleration. So, now it is calculated by the average acceleration is equals to the change or delta v over delta t. And your delta v is equals to the v prime minus v. Your v prime again is your final position, or final velocity, rather, minus the initial velocity. So that's your delta v. Next is your instantaneous vector that is found by taking smaller and smaller values of delta t and corresponding corresponding smaller and smaller values of delta v. Now, instantaneous acceleration at time t is a vector that is found by taking smaller and smaller values of delta t, corresponding smaller and smaller values of delta v. So that your A can be calculated as dv over dt. Again, it's like of the instantaneous, so like instant in an instant. What is this? What is the acceleration in this time interval? So change A, kunin mo lang yung um, velocity niya. So you have to find the final and initial velocity, divide mo yun sa dt, and you have your instantaneous acceleration. So what if you have a what do you call this, given na position, tas hinahanapan ka ng acceleration. So how can we do that? How can we compute the acceleration using position and time, no? If given tayo ng position and its time. Simply, di ba? If your A is equals to dv over dt, and we all know that velocity is equals to ds over dt, we can just substitute the value of your dv to our equation sa acceleration. So that will be d of ds over dt over dt. Di ba? Sakto. Next, times natin d times ds over dt, it will be now d squared s over dt squared. Now, it will be on in meters per second squared or feet per second squared. So, basically, if you have your equation na may given ka na equation and like variable or your equation na kunwari um, in terms of t, no, you have to uh, derive it. No, you're going to derive it two times so that you can get your acceleration. Kumari, if you have equation for your displacement or your position, so you're going just to differentiate it two times so you can have your acceleration. Okay, don't worry, we will have an example later on. So, acceleration daw, both average and instantaneous acceleration can be either positive or negative. Take note. And then if the particle is slowing down or its speed decreases, the particle is said to be decelerating and therefore will act to the left or opposite sense to the velocity. Okay? Take note, if it's slowing down yung or yung velocity niya is the decrease or speed decreases, it's said to be decelerating. Therefore, your acceleration will be negative in manner. Okay? Kasi opposite sa sense of velocity. So, kung biglang humina, means that it's decelerating. If it, of course, if it's speeding up, of course, it will be acceleration. So constant velocity means zero acceleration. Take note, constant velocity means zero acceleration. Since, di ba, we define that acceleration is a change in velocity per unit of time. So if walang changes ng velocity mo, it means walang acceleration na nangyayari. So it will be equal to zero. So that will be zero acceleration if sasabi kang constant yung velocity mo, hindi nag-change yung velocity in that time interval. So, wala kang acceleration na nangyayari. Okay? That would be, take note doon. So, important differential relation involving the displacement, velocity, and acceleration. Now, there's formulated mga derived formulas na nag-relate ng displacement, velocity, and acceleration. It means that if you have a given two parameters, you can solve the other one. Kunwari, if you have your displacement and acceleration, you can solve your velocity. If you have velocity in your acceleration, you can solve displacement and so on. Anong siya? So first formula or first relation is V is equals to ds over dt. So we have here sa on your right side. So ds over dt, no? V is equals to ds over dt, or it can be manipulated as dt over ds over v. So that's your first relationship. Or first relation. So second relation is A is equals to dv over dt, no? Or dt is equals to dv over A. Now, why we are doing this? Diba? Since meron silang um, similarities, yung velocity and acceleration, why not combine these terms together? So, equating the differential dt equations, we can have our third relation sa ating displacement, velocity, and acceleration. So, how can we solve acceleration using displacement? Displacement and time lang only, di ba? So, we can solve the acceleration by giving this equation. So again, there's three relation here. So v is equals to ds over dt, a is equals to dv over dt, and your ads is equals to dv v dt. Now, paano to nangyari is that we equate the two but in terms of dt and we combine them. So ds is equal now, ds over v is equal to dv over d. Okay, so cross multiply. So we have your ADS is equals to VdV. So again, your A is your acceleration, your ds is your displacement, is equals to V, your velocity, and your change in velocity, yung dV. That's our third relation. So when the acceleration thou is a constant, we call that constant acceleration. Each of three kinematic equations, 2.1, 2.2, and 2.3, can be integrated to obtain formulas that relate constant acceleration, velocity, position, and time. So we can integrate this equation so that we can have our formula to solve this um, motion parameters. Okay? So velocity as a function of time. So how can we create a formula from that? So we have to integrate. So integrate equation 2.2. Ito, take note, 2.2. AC is equals to dv over dt. Again, your a sub c is your, it means that constant acceleration. Okay, so assuming that initially v is equals to v sub 0 when t is equals to 0. Okay, so how to derive that? So from A is equals to dv over dt, we can actually manipulate that into dv is equals to a sub c dt. Again, same lang yung ac dito at a. Okay? Next, we differentiate both sides. No? Differentiate dv. No? We have the integral of dv from v sub 0 to v, and then ac dt is integral of AC dt from 0 to t. And then, di ba sa rules sa integration, we can just get the AC out since it is constant. So, always labas yung mga constants sa integration process natin. So, matitira is integral of dt from 0 to t for our right side. So, sa ating left side is dv, integral of dv, no, from v sub 0 to v. So we have to, if we integrate that and um, integrate that from 0 before from initial, so we have your v minus v initial is equals to AC times t minus 0, since from 0 to t. So we have your v minus v sub o is equals to AC times t times 2. So we have your first formula. So to solve your final velocity, again, your final velocity is equals to initial velocity plus your constant acceleration times time. Ito yung final of like your time sa final position mo or final velocity. So you can solve your final velocity by getting the sum of initial velocity and the a times t. Next is your position as function of time. So, paano ito masosolve? Next is, we integrate equation 3 daw, 2.3 daw. This is ADS is equals to VdV, or V is equals to DS, or, no, that's your 2.1. Assuming that initially S is equals to S sub 0 when T is equals to 0. So, we have your position, no? Our velocity is equals to ds over dt. So, we have your ds is equals to v dt. Diba? Again, um, let's add, this is 2.1. Okay, so your position as function of time, integrate down the equation 2.1, v is equals to ds over dt, assuming that initially s is equals to s sub 0 when t is equals to 0. So to derive that, we have your v, no? V is equals to ds over dt. So we can manipulate that to ds is equals to v dt. And next is we are going to integrate both sides. Or first, we have 2.4. Equation 2.4, we can substitute the value of our v, since v is equals to v sub 0 plus AC times t dt. So next is to integrate that both sides. So we have the integral of ds from s sub 0 to s is equals to integral of v sub o plus act dt from 0 to t. Next, we integrate both. Distribute the dt on each terms sa ano natin, v sub o plus ac times t. No? So we have the integral of ds from 0 to s sub 0 to s is equals to integral of vo dt, v sub 0 dt from 0 to t plus integral of act dt from 0 to t. So we have the integral of our left side is s minus s sub 0 is equals to v sub 0 times t minus 0 plus ac. So your we have a t dt. So that will be t squared over 2. Diba? T squared over 2. So we have your AC is equals to T minus 0 squared over 2. That's how you integrate a T. So again, the integral of T is T squared over 2. Diba? So that's how you integrate a variable T. So S minus S sub 0 is equals to V sub 0 times T minus 0 plus AC times T minus 0 squared all over 2. So we have your simplest form. So we have s minus s sub 0 is equals to v sub 0 times t minus 0 plus 1 half ac t squared. So simplify pa natin. So s minus s sub 0 is equals to v sub 0 times t plus 1 half ac t squared. So to find our final position is equals to s sub 0 plus v sub 0 times t plus 1 half act squared. So why are we doing this? So that ma-relate nyo kung saan to nanggaling na mga formula. So again, is we just have to integrate, no, yung mga relation nila. If you have your two parameters, your v ds over dt, your three parameters, you have integrate that so that you can. Again, we integrate that kasi we are given na constant yung acceleration natin. Okay? So, how to solve position in a constant acceleration? So, we integrate those, no? To have your formula and constant acceleration. Kung hindi constant acceleration nyo, you can use this formula. Itong v is equals to ds over dt. If you are given not the exact velocity talaga, means you have the equation, pag binigyan ka ng equation sa problem, hindi nyo magagamit to. Of course, you're going to integrate or differentiate those equations so that you can answer the required answer. Okay, so again, it's just a derivation, no, on how to solve position, velocity, acceleration, no, position and velocity in constant acceleration. So, yun lang baga yung pinapakita lang natin kung paano natin nakikuha itong mga formula na to. So again, that's your 2.5. Equation 2.5. Your S is equals to S sub 0 plus V sub 0 times T plus 1 half AC T squared. Now, what is velocity as a function of position? So next, we are going to find velocity kung may function siya sa position. Kung your position is a function or given is how can you solve the velocity as a function of position? You are going to integrate equation 2.3 v dv is equals to ac ds, no? Assuming that initially v is equals to v sub 0 at s is equals to s sub 0, or solve for this t in equation 2.4, ayan, and substitute into equation 2.5. Again, integrate the 2.3, tapos you're going to solve for t in equation 2.4 and then substitute that into 2.5. Now, let's do that one. So, derivation using 2.3. Ayan. So, VDV is equals to ACDS. Yun lang to ha. ADS is equals to VDV. Don't be confused. So, that will be VDV is equals to ACDS. If we integrate both sides, we have integral of VDV from V sub 0 to V is equals to integral of AC ds from s sub 0 to s. So that will be v squared minus v sub o, or u 0 squared, all over 2 is equals to AC times s minus s sub 0. Again, v squared minus v sub o squared is equals to 2ac s minus 2. We multiply both sides by 2 para ma-simplify natin sa left side. Okay, our goal here is to solve the velocity or final velocity. Okay, so dapat yung matitira dito is your velocity. Next, we multiply, if after we multiply both sides by 2, here's the result. So, to solve your final velocity, you have your v squared is equals to v sub 0 squared plus 2ac times s minus s sub 0. Again, what happened to this? V dv, diba? V squared over 2 lang. So, if you integrate that from v0, v sub 0 to v, here's your result. And transfer mo lang yung negative v sub 0 to squared to the right side. So, you have your file formula. V squared is equals to v sub o squared plus 2ac times s minus s sub 0. So, again, we already solved the... If you have if you don't have the given time, no, and the given parameter is the position, you could still solve for your velocity using your ace, your acceleration, and your position. Again, as what I've said kanina, if you have the two parameters and constant acceleration, and constant acceleration, if you have two parameters, you can solve the other one parameter. Kunwari, if you are given by acceleration position, you can solve for your velocity. If you are given by acceleration and time, you can solve your velocity. As also your displacement or your position. You can solve that one using this formula. Okay? So, let's have an example, no? Para ma-apply natin yung mga concept to solve problems related sa rectilinear translation, no? For constant acceleration. Now, for the example 1, the car moves down in a straight line such that for a short time, its velocity is defined by v is equals to 3t squared plus 2t. And its units is feet per second. Take note, where t is in seconds. Determine the position and acceleration when t is equals to 3 seconds. When t is equals to 0 and s is equals to 0. These are your final, your initial parameters sa pag-move ng car mo. So, we have given the velocity or the function, no? You have your v is equals to 3t squared plus 2t as a function of time. Again, if you recall, velocity as a function or function of time. Velocity as a function of time. So we can use that formula. So to solve that, you have your given. We have your equation of your velocity is equals to 3t squared plus 2t feet per second. Your time is equals to 3 seconds. Your final time or your final position or final time is 3 seconds and initial time is 0 and your initial position is at 0 at the origin. Ayan. So, ang required daw is the car's position when t is equals to 3 seconds. So, ano yung distance niya from the origin at 3 seconds and its acceleration at 3 seconds. So, we can solve that one using the equation. So, to solve that, a car's first is we're going to first solve the position of the car at 3 seconds. So solving position when t is equals to 3 seconds using instantaneous velocity formula, or your v is equals to ds over dt, where t is equals to 0 and s is equals to 0. Now, take a class, if you are given by a equation, um, basically, ang gagamitin nyo lang is sa mga trend na mga answer nyo is that you're going to differentiate or integrate. Yun yung baga twist dito sa if you are given by an equation, hindi yung exact value of your velocity or ano pa yung mga motion parameters natin, no? So again, if you are given equation, basically expect nyo na mag-differentiate or integrate kayo dyan to answer the required. So, going back, so we have to solve for our, again, position, no? Ano yung position natin after 3 seconds? So, we have our formula, V is equals or relation, V is equals to ds over dt, no? Sakto din na yung V natin is a function of time, yung 3t squared minus, ano ba yun, 2t, if I'm not mistaken. So, we have your ds is equals, or V is equals to ds over dt, and if substitute natin yung value sa ating t, yung given, which is 3t squared plus 2t. So we have your ds over dt is equals to 3t squared plus 2t. Ayan. So, multiply both sides by dt. So, matitira na lang dito sa right side is ds. 3t squared plus 2t dt. Now, in this part na, you can now integrate both sides so that we can have our position at 3 seconds. So if we integrate both sides, we have your, di ba? Initial natin is 0 to s. And this s is our required or our dapat natin makuha, di ba? So integral of ds from 0 to s is equal to integral of 3t squared plus 2t dt from 0 to t. Integrate both sides. So we have s minus 0 since ds, integral of ds is s. So s minus 0 is equals to 3. Labas natin yung constant. Then integrate each terms. So integral of t squared is t cubed over 3. And then the integral of t is t squared over 2. Okay? So simplifying, we have 3 times, 3 divided by 3 is 1. So your coefficient now for your 3t cube will be 1. So t cube plus same sa second term, t squared. So this is your position. Now, if to solve the exact value for our position, we can now substitute the value of your 3 seconds. So to solve for your position at 3 seconds, you can now substitute the value 3s. Diba? So, your position daw at 3 seconds will be s is equals to 3 second cubed plus 3 seconds squared. So, to solve that, 3 is, your position at 3 seconds will be 36 feet away from your origin. Again, we did we integrate the equation, no? From your given na velocity is equals to 3t squared plus 2t. We integrate that and then we arrive at this answer. And after you integrate, you can now substitute your 3 second. Hindi yung directly ninyo na pag integrate. Kumbaga, if you're given sa velocity, if you are required to get the position on that equation, you're going to integrate that. Now, if you're required to find the acceleration of that equation sa velocity, you're going to the opposite, the differentiate. So you can solve for your acceleration later using that differentiation. So again, solving acceleration when t is equals 3 seconds using instantaneous acceleration formula a is equals to dv over dt. Yan. So I'm saying. So we have a is equals to dv over dt. So we can solve our acceleration by differentiating the given equation of the velocity. Yan lang kadali. So we have to, if we differentiate this, so the derivative of 3t squared will be 6t. And the derivative of 2t will be 2. Now after you differentiate, you can solve for acceleration by substituting the value of the final time of your car. So, or your of the movement. So 60 plus 2. Now, when t is equals to 3 seconds, your acceleration will be 6 times 3 plus 2. So 6 times 3 is 18 plus 2. So you have your acceleration be 20 feet per second squared. Now take note, you don't have to include the unit when you're nandun ka pa sa pag-integrate or pag-differentiate. You can just omit on putting the they call this units. You can actually put your units at the end of the answer. So But always take note, dapat may unit yung final answer mo kasi we'll never know what if that's your velocity or acceleration or your position if walang unit. So 20 feet per second squared for your acceleration at 3 second. Again, if you are going to solve for your position na given yung velocity na equation, if you're going to solve your position, you're going to integrate. If you are going to solve for your acceleration, you're going to differentiate. Of course, the given velocity. So, ganun lang kadali to solve your motion parameters using equation ng mga problems. Yan. So, next example. So, a small projectile daw is fired vertically downward. As you can see as sa picture sa kanan. So, we have a small projectile is fired vertically downward into fluid medium with an initial velocity of 60 meters per second. Now, due to the drag resistance to the fluid, the projectile experiences a deceleration or biglang humina yung velocity natin or biglang humina yung motion ng natin yung ano ba to bala ba to oo bala. Now we are given an equation of acceleration which is negative 0.4 v cubed where v is in meters per second. Determine the projectile's velocity and position after 4 seconds it is fired. And so the question here is the velocity and position. And we are given by the equation of acceleration. So to solve that, we are going to solve for our instantaneous velocity and position. Okay. To solve for that, we have a given where a is equals to negative 4.4 v cubed given with t is equals to 4 seconds is our final time, no? Final movement or motion. And we are required to find the position and the velocity 4 seconds after it is fired. So let's start with letter A. And also, if you are going to solve for this kind of problem, you need to construct or you need to draw your coordinate system so that in your position, no, or your kanang your direction na ano nyo ng object if it is moving downward, upward, left or right para malaman natin kung saan yung ano yung direction ng motion natin. So the position coordinate with respect to the region located at O is positive downward since the motion of the projectile is downward. Okay? So to pakita lang natin yung coordinate system natin as nandito lang. Ayan. So our origin is sa initial na pag-touch sa water ng bullet. No? So this is our axis. So if pa-downward siya, we are going to assume that our positive direction will be downward since the motion is pa-down siya. So we are going to assume that our positive downward. Okay? So solving velocity v using instantaneous acceleration, formula A is equals to dv over dt. When v initial velocity is equal to 60 meters per second, we're also given by this, and t initial is equal to 0. Okay, so your formula to be used is A is equals to dv over dt, excuse. And your A daw is 0.4 v cubed is equals to dv over dt. And we can transform that further into dv is equals to negative 0.4 v cubed times dt. And multiply lang natin dito both sides by dt so that matitira dito yung dv. And we have our after that you have your dv is equals to negative 0.4 v cubed times dt. So next, divide both sides by negative 0.4 b cubed so that to combine like terms, if your dv is here, dapat yung v natin na nandito din. Para pag nag-integrate tayo, walang issue or walang bawal. So, if your dv, dapat v yung nandito. So that we have no issue in pag-integrate natin mamaya or differentiate. So, integrate both sides, no? So, I have integral of dv over negative 0.4 b cubed from v sub 0 to v is equals to integral of dt initial time to time to given time. So next is what's our initial velocity. So our initial velocity is given by 60 meters per second to v. This is our required or ito yung hinahanap natin dito. So times dv over negative 0.4 v cubed is equals to integral of dt. Our initial time is 0 and final time is t. So if we integrate this one, parang medyo um, mahirap, diba? Kasi nasa baba yung natin variable. So kind of complicated. But if you transpose this denominator to numerator and just changing the exponent into negative, so you can just form it like this, di ba? So it is now easily to be integrate, di ba? So we have nilabas natin yung constants and integral. So we have 1 over negative 0.4 integral of v raised to negative 3 dv from 60 to v is equals to integral of dt from 0 to t. To integrate that, we have 1 over negative 0.4 times v raised to negative 3 plus 1. So we are now integrating this term. So we have all over negative 3 plus 1 from 60 to v is equals to t minus 0. Next is let's simplify na natin. So we have negative 1 over negative 0.4 times negative 1 half, since negative 3 plus 1 is 2. So we have negative 1 half or negative 1 over negative 2 times v minus 2 from 60 to v is equals to t. Next, we multiply the 0.4 times 2. We have 1 over 8. Positive, negative times negative is positive. And then, if we integrate or we apply na yung integration, so we have your 1 over v squared minus 1 over 60. Since final minus initial if we integrate na. Or upper limit or lower limit. Diba? So, this is your upper limit, your v, and your lower limit. So, we have upper limit minus lower limit. So, 1 over v squared minus 1 over 60 times 1 over 60 squared is equals t. Now, we have your divide both sides by 1 over 0.8. No? So, we have, natitira lang natin dito is 1 over v squared minus 1 over 60 squared is equals to t all over 1 over 0.8. And then, i-transpose lang natin tong second term to the right. So, matitira dito ang 1 over v squared is equals to 0.8t plus 1 over 60 squared. Next is we multiply both sides by v squared, no? Para magiging numerator siya sa kabila. So we have natira natin sa right sa left side is 1 is equals to v squared times 0.8t plus 1 over 60 squared. Now divide both sides by 0.8t plus 1 over 60 squared. So we have your v squared is equals to 1 over 0.8t plus 1 over 60 squared. And squared, we have the square root for both sides. So matitira natin dito is v equals to square root of 1 over 0.8t plus 1 over 60 squared. And here's our final na formula to solve our v or our final velocity na hinahanap natin. So we have v is equals to 0.8t plus 1 over 60, no? Squared raised to negative 1 since we transpose that to numerator. So we are going to change its exponents from positive to negative raised to 1 half. Next, we multiply the exponents, no? Negative 1 times 1 half. So magiging negative 1 half. So next, we substitute now the given time. So what is the velocity at 4 seconds, or your when t is equals to 4 seconds? So simply just going to substitute the value of the t to have your velocity. So we have v is equals to 0.8 times 4 seconds plus 1 over 60 times 1 over 60 squared raised to negative 1 half. Now, if you calculate the calculator, you'll have your final answer for your velocity. V is equals to 0.559 or 0.559 meters per second. So, grabe yung drag resistance ng water. Biglang drop ng velocity, no? Yung initial 60 meters per second naging 0.559 meters per second. So, nag-decelerate talaga or like humina. So, that's your velocity at 4 seconds. Now, next required naman is what is the position at S or what is your position at 4 seconds, di ba? So, solving position using instantaneous velocity again, no? Formula V is equals to ds over dt when V sub 0 is equals to 60 meters per second and S is equals to 0 when T sub I is equals to 0. Now, if you're um, confused sa V, bakit V yung ginamit natin kung given natin na yung A, diba nasolve natin yung equation ng V by integration sa given natin sa acceleration dito. Ayan, this is your V na gagamitin natin para masolve natin yung acceleration para hindi na tayo mag-integrate ulit to solve for our position here. So we're just going to use that one. So V is equals to ds over dt, and then we already solved this. What is V? So we can just solve that directly. So substitute the V formula obtained from our first required kanina. So we have your V. Ayan. Ito yung V na I was saying. Ano? So we have V is equals to 0.8t plus 1 over 60 squared raised to negative 1 half. So if we apply that one, we can now find the position. And it is also expressed with respect to time, diba? So 8.8t. So we can just integrate that. Okay? No, I think differentiate, not integrate. Sorry. So, to solve for your position, no, sakto, integrate talaga. So, we have ds over dt is equals to 0.8t plus 1 over 60 squared raised to negative 1 half. So, multiply both sides by dt para matira dito yung ds. So, your ds is equals to 0.8t plus 1 over 60 squared raised to negative 1 half dt. Integrate both sides from 0 to s and 0 to t. So we have your integral of ds from 0 to s is equals to integral of 0.8t plus 1 over 60 squared raised to negative 1 half dt from 0 to t. Yeah, so integral of ds from 0 to s is equals to integral of 0.8t plus 1 over 60 squared raised to negative 1 half dt from 0 to t. Now, we'll let this u para madali lang natin i-integrate, diba? So, u substitution yung gagamitin natin to integrate these terms. So, if we let u to be 0.8t plus 1 over 60 squared, and we we're going to find the du. So your du will be 0.8 na lang. Kasi yung 0.8t, the derivative of 0.8t will be 0.8 since yung exponent ng t is 1. So 1 minus 1 is 0. So t raised to 0 is 1. So we have your 0.8. 0.8 na lang yung matitira sa 0.8 t after we differentiate that. Now, sa derivative naman, the derivative of a constant is always 0. So, matitira natin sa du natin, it will be 0.8. And we are going to find the dt para homogeneous yung integral natin. So, hindi natin ma-integrate if u tapos dito, we cannot integrate that. So, we are going to find the du. Ano yung equivalent to du sa dt. So, if we express this in terms of dt, it will be dt is equals to du over 0.8. If we divide both sides by 0.8, diba? So, your dt will be du over 0.8. Now, we substitute the value that we um, express here. So, we have from this integral, it will be now the integral of ds from 0 to s is equal to integral of u du from 0 to t. So, the integral of this will be s is equals to 1 over 0.8. Since your s is 0, so matitira lang dito is s minus 0. So, matitira na lang is s. Now, if you integrate the u raised to negative 1 half plus 1, di ba? So, we have your s is equals to 1.08. So, saan ang galing itong 1 over 0.8? From this dt. Kasi, sinabstitute mo itong du eh. Itong dt sa dito. So, yung 1 over 0.8 ang galing sa dt. So, we have your s is equals to 1 over 0.8 times the integral of u, negative 1 half, is u raised to negative 1 half plus 1. Same sa denominator, negative 1 half over negative 1 half plus 1 from 0 to t. So, negative 1 half plus 1 is 1 half. So, you have your, now 1 over 0.8 times 0.5 will be 2.5. So, we have s is equals to 2.5 times u raised to 1 half. Now, substitute back your value of your u, this one. So, you have your s will be, ayan, so s equals to 2.5. The value of your u is this one. If you evaluate that from 0 to t, here's your final equation. So, we have your s equals 2.5 times 0.t plus 1 over 60 squared raised to 1 half minus 0.8 times 0. Dito yung time eh. At 0. Plus 1 over 60 which is 0. So, cancel out ito. So, matitira na lang will be this. So, cancel out to. So, matitira itong 1 over 60 squared. So, we have your s is equals to 2.5 times 0.t plus 1 over 60 squared raised to 1 half minus 1 over 60 squared raised to 1 half. And to simplify that one, and so we have your s is equals to 2.5 times 0.8t plus 1 over 60 squared raised to 1 half minus 1 raised to 1 half is 1. Then 60 squared raised to 1 half is 60. Yun yung natira. So you can now substitute your t is equals to 4 seconds. So what is the position at 4 seconds? Using this, our solve equation. So we can now answer the required letter B. So we have your s is equals to 2.5 times 0.8 times t, which is 4 seconds, plus 1 over 60 squared raised to 1 half minus 1 over 60. If you calculate that, it will be equal to 4.43 meters. So that's your final answer. So I think that's all for your constant acceleration. Okay? So see you on your next lesson will be your free falling bodies. Okay?